Hi everyone, welcome to My Max Academy. In this video, we'll continue with the chapter Matrices from your 12th standard CBSE Mathematics. I'll continue from example 25 in page number 96 of your textbook. So it says find P inverse if it exists. So we need to find the inverse of this matrix P using elementary row or column operation. Fine, and we have to find the inverse of this matrix P. So we will use elementary row operations to find the inverse of this P. We can either use elementary row operation or column operations. We'll use row operations. So the solution is, we'll try to find. So for row operations, if you are applying a row operations to 2 cross 2 matrix, I was telling you in my previous video the steps that we need to follow to find the inverse of a matrix, a 2 cross 2 matrix. So the first step is, if I put the box, then it is 1. If I put circle, it is 0. It is also circle 0. This is also box. So the first step is, we have to get the first step to make this matrix, which is our unit matrix. It is like 1, 0, 0, 1. Right? So before we go to the steps, let's write the first step, that if you are applying the row operations, then we have to write this Pi as I into P. We have to apply the matrix, we have to write the matrix Pi as identity matrix into P. So identity matrix into P will give you P. So P should be written as I into P. Then we should write the matrix P, which is 10, minus 2, minus 5, 1. With I matrix, that is 1, 0, 0, 1. With P, you write as P. Now we should convert this matrix into an identity matrix in this form, and we will follow the steps that I am going to tell you, which I had told in my previous video also, where we did how to find an inverse for a 2 cross 2 as well as 3 cross 3 matrix. So when we are applying the row operation, the first step is to make this as 1. So that is step 1. This square box. Square means you have to make that element as 1. Second step is, we are going to apply the row operations. So if you are applying the row operations, then the corresponding other elements in that particular column should become 0. So which means this is your second step, S2. You should make this as 0. That is your step 2. S2 is step 2. Then third step is you have to make this as 1, which is step 3. And you have to fourth step is you have to make this element as 0. That is step 4. So this is the order that we will follow if you are going to apply the row operation. So first step is to make this one as 1. Box means 1, which means we have to make this element as 1. Now using some row operations, either we can use row 2 or we can use the row 1 itself to make this as 1. We can't use this because if I do 10 into something plus 5, we will not get 1. So using R2, we may not be able to make this 1 easily, but whereas what we can do, we can divide 10 with 10. That's the easy way to make this as 1. So the operation that we are going to apply is R1 is R1 by 10. I'm going to divide each element by 10 or multiply by 1 by 10. So if you do that, then 10 by 10 I'll get 1, which is this step 1, to make that as 1. So we get here 10 by 10. So row 1 is 10 by 10 is 1. Then minus 2 by 10 is minus 1 by 5. Second row, no change. Then equal to, here also we should apply the same operation, should be applied only to this matrix, and nothing should be applied to this matrix. So this will continue to be P, right? So row operations, I was telling you in a matrix equation, if you are applying a row operation, the row operation should be applied to this matrix, and then on the right side, if you have 2 matrices, the row operation should be multiplied only to the first matrix, which is the identity matrix. The second matrix, there is no change, it's intact. Second matrix is intact. First matrix we have to change. So R1 by 10 is 1 by 10. Then this is 0 by 10 is 0. And the row 2, there is no change, 0 and 1. So, and this is P. So what we have done here, we have made this element as 1. This one should be 1. That is step 1, which is we have made this. The second step is to make, this is S2, second step, which means we have to make this element 0. What is the corresponding element? We have to make this element 0. We have to make this element 0 using this element. Whatever we just made it as 1. Using this element, we have to make this as 0. And that is very easy because we can do, this is in which row? Row 2. Row 2 is equal to row 2, which is minus 5 plus 5 into row 1. So we can apply the operation row 2 implies row 2, which is minus 5 plus 5 times 1. 1 is row 1. 1 is in row 1. 5 times row 1. So if you apply this operation, what do we get? So my row 1, there is no change. My row 2 is minus 5 plus 5 times. So minus 5 plus 5 times or minus 5 plus 5 times 1 is 0. Then 1 plus 5 times minus 1 by 5, that is also 0. That is also becoming 0. That is equal to, here if you go here, you will get your R1 no change. Your R2 becomes 0 plus 5 times R1. 0 plus 5 times 1 by 10 will give you 1 by 2. Then 1 plus 5 times 0 is 1. And this is P. Clear? So now what has happened? So when you are trying to make this element as a identity matrix, a 1 0 0 1 into this matrix, in the process we are applying series of row operations. Suppose if you get a particular row or a particular column with all zeros, here row 2 is completely become 0. Then we have to stop the inverse process and say that inverse does not exist. When we are trying to make this as 1 and then this as 0 and this as 1 and this as 0, this matrix slowly, in that process, suppose if we encounter a situation where a particular row or a particular element, all the elements have become 0 in a particular row or a particular column. In a particular row or a particular column, if all the elements become 0, then we have to stop the inverse process and we should say that inverse does not exist. Inverse does not, because we cannot get, if you get into a, see here, if you see the row 2 is becoming 0, which means this particular matrix does not have an inverse. Right? So therefore we will say, since all elements of R2 equal to 0, all the elements of row 2 is 0, therefore P inverse does not exist, which means P does not have an inverse. P does not have inverse, or you can say P inverse does not exist. And then we should stop the process. Right, so this particular matrix does not have an inverse. It's not necessary that all the square matrices have inverse. Right? There are square matrices which do not have inverses, and basically that you will study in determinant. If the determinant of that matrix is 0, we call that matrix as a singular matrix, and singular matrices don't have inverses. I will teach you in the determinant chapter. When you see the videos of determinants, you will understand that what is a singular matrix, what is a non-singular matrix, and all that. So inverse exists only for non-singular matrix, which means determinant of A is not equal to 0. You can watch my determinant video, you will understand better that. So here a simple understanding is, if any particular row or any particular column becomes all the elements as 0, if all the elements of a particular row or column become 0, then we will say inverse does not exist, and we should stop the problem here. So this is the end of example 25. Now we will go to exercise 3.5. All of you can pause the video and take the notes. I'm going to the next problem in exercise 3.5. Finishing this. So we are going to find the inverse. I'll do few problems. The rest you can do it by yourself. The same logic. So exercise 3.4 in page number 97 in your textbook. I will do the first problem. So suppose the given matrix A is 1 minus 1 2 1 3. That's a given matrix. You need to find the inverse of this matrix. We have to find the inverse of this matrix using elementary row or column operations. So again we will use row operations to find the inverse. So for the row operation, the logic is this. Right? These are the steps that we for the column it's a different step, order will be different. Right? So the first step will be solution to apply the row operations. Right? We'll say we will find the inverse. We will find the inverse using row operations. We'll find the inverse using row operations. So which means for row operation, the first step is the matrix A should be written as I into A. I into A. So now substitute A. A is what? 1 minus 1, 2, 3 equal to I is 1, 0, 0, 1. Then this A you should write this as it is. Now we should apply series of steps to this matrix so that this becomes an identity matrix. This becomes an identity matrix. So for that, which means we have to follow these steps. This is for row. For applying row operation, this is order. The first one is you have to make this element as 1. Box means 1, circle means 0. So we have to make this element as 1. What is this element? It's already 1. It's already 1. So we don't have to do the step 1 because it's already 1. Now step 2 is we have to make this element. Step 2 is this element should be circle means 0. This should become 0. We have to make this as 0 using this element 1. We can easily make this as 0 using 1 because the moment you get 1 you can make the remaining elements 0 easily. So 2 can be made as 0. This particular element can be made as 0 by applying the row operation as R2. It is in the R2's, it is in the row 2. So row 2 implies row 2 minus 2 times row 1. 2 which is R2 minus 2 into 1 will give you 2. Again 2 minus 2 will become 0. So we're going to apply this operation on this. So you get my row 1, there is no change. Row 2 is row 2 minus 2 times row 1. So 2 minus 2 times 1 is 0. Then 3 minus 2 times minus 1. So 3 plus 2 is 5. Fine. 3 plus 2 is 5. That is equal to, we'll apply the same operation here. So row 1 there is no change, 1, 0. Row 2 is 0 minus 2 times R1 is minus 2. Right, 0 minus 2 into R1, R1 is 1. So 0 minus 2 times 1 is minus 2. Again 1 R2 minus 2 times R1, 0 is 1. So 1 minus 2 times 0 is 1. Then I will write A. So what we have done, we have made this element as 0. That is second step. A third step is we have to make this element, which is exactly this element, as 1. Now how can we make this as 1? Very easy. We'll divide each element in row 2 by 5. That is the easy way to make that as 1. So we will say R2 implies R2 by 5. R2 implies R2 by 5 means every element of row 2 I am going to divide by 5. So first row no change. Second row is 0 by 5 is 0. 5 by 5 is 1. And we have to apply the same operation here. Row 1 there is no change. Row 2 is each element should be divided by 5. Minus 2 by 5. Then 1 also divided by 5. So 1 by 5. This is A. Fine. Now what is the next step? So we have made this as 1. The fourth step is we have to make this element as 0, which means we have to make this element as 0 using this. We have to make this element as 0 using this. Right? So how do we make this element 0 using this? You will add them. So this element should be made as 0. This element is in row 1. So I will say row 1 implies row 1 plus row 2. So then my row 2 no change, 0, 1 equal to, here also I will write my row 2 minus 2 by 5, 1 by 5, no change to that. A is A. Now R1 is R1 plus R2. So this plus this is 1. 1 plus 0. Then minus 1 plus 1 is 0. Similarly here 1 plus minus 2 by 5 is 3 by 2. So 3 by 5. 1 plus minus 2 by 5. R1 is R1 plus R2. Then this plus 1 by 5 will give you 1 by 5. Fine. So what we have got here, we have got this as identity matrix. So therefore this is the inverse of A. So what is your A inverse? Therefore A inverse is, we have applied all the 4 steps. We have made this as 1, 0, then this is 1 and this is 0. So when this becomes identity matrix, this is your inverse. So what is your inverse? Inverse is 3 by 5, 1 by 5, minus 2 by 5, 1 by 5. So this is the inverse of A. This is the inverse of A. Fine. Now if you multiply your A with A inverse, A into A inverse, you will get identity matrix. You will get 1 0 0 this matrix, which is what this is showing here also. But you can actually multiply and check. Multiply this and this, you will get identity matrix. So this is how we will find the inverse, right? Now I will do the second problem. All of you can pause the video and take the notes. So second problem, this is for row, and say here row, this is for row operations. Row operations, this is the, right? So all of you can pause the video, take the notes. I'll go to the second one, which is find the inverse. Second problem, A matrix equal to 2 1 1 1. So 2 1 1 1. And to find the inverse of this matrix, we'll find the inverse using, I will do this using column operations. Column operation. So one I did it with the row operation. Now I'll do with the column operation so that it becomes easy for you. Fine. So easy to understand how it is. So for the column operation, the first step that we do is, I will erase these also. Fine. So column operations. So this tells you how to, what is the order in which the steps have to be followed. I'll erase this also. Fine. So the first step is you have to write the given matrix A as A into I. That write A as A into I. In for row, if you are applying row operations, you will get write A as I into A. A equal to I into A if you are using row operations. For column operations, A is equal to A into I. A should be written as A into I. Now what is A? Let's substitute 2 1 1 1 equal to this A you write as it is, and I alone you substitute 1 0 0 1. Now we will apply series of column operation to this matrix so that this becomes a identity matrix. This should become like 1 0 0 1, like this matrix. You have to get it here, right? So for that, now what is the order in which the steps have to be done, right? So the first one is, this is your first step, is you have to make this element as 1, S1, right? Step 1. S1 means step 1. Step 1 is box. Box means you have to make that particular element as 1. Then since we are applying the column operation, after you make this as 1, you have to make the remaining elements in that column as 0, which means in that row. You have to make the remaining elements in that row as, when you are applying column operation, you will make this as 1. Then the remaining element of that row should become 0. Since this, the second step is here, this should become 0. And third step is this should become 1. And fourth step is this should become 0. This is for your column operation. S4. Fine. So this is your step 1 to make this 1. Then you have to make this 0 using this 1. Then make this as 1. Then make this as 0 using this 1. That is fourth step. So first step is what? You have to make this one as, this one should be made as 1. So we can make this one as 1 either by dividing the entire each element by 2, then it will become 1. That is one way. Or we can even do R1 is R1 minus R. If I subtract these two, 2 minus 1, I'll get 1. Right? So either you can divide by 2 or you can use other row to make it 1. So we'll do the other row. We'll say R1 implies R1 minus R2. Oh, sorry. I'm going to use the column operation, right? Sorry. So column operations. So how do we do? Make this as 1 using column operations. Either I can divide this entire column by 2, or I can use this minus this. I can say C1 minus C2 will give me 1 here. So I can say C1 implies C1 minus C2. If I do that, my column 2 no change. Always write the one which doesn't change. Then here also A, my column 2 does not change. So 0 1. So column 1 is changing. Column 1 is C1 is 2 minus C2. Sorry, 2 minus 1. This one. 2 minus, this is C1 is 2 minus 1 is 1. Then 1 minus 1 is 0. So here also 1 minus 0 is 0. 0 minus 1 is minus 1. Clear? Fine. So this is how we make it. Make the first one. So I'm using the column operation. So C1 is C1 minus C2. So this minus this is 1, this minus this is 0. Again this minus this is 1 minus 0. 1 minus 0 is 1 and 0 minus 1 is minus 1. Clear? So C1 is 1, 1 minus C2, C2 is 0, 1 minus 0 is 1, 0 minus 1 is minus 1. Now the second step is we have made this as 1. Second step is to make this element as 0. This element as 0 using this one. How will you make this as 0 using this? This is in the second column. So we have to make this 0 means this minus this 1 minus 1. So I will write C2 implies C2 minus C1. So I will write my C1 as it is 1 0 and A into I will write my C1 as it is again 1 minus 1. 1 and minus 1. Fine. Now let's do this. Let's do C2 is C2 minus C1. C2 is this minus this 0. Then this minus this is 1. Then again C2 minus C1. This is minus 1. This minus of minus 1 will give you 2. Will give you 2. Now we will stop the process here. We'll solve the process because this has become unit matrix. I mean, which is identity matrix. We got 1 0 0 1. So when we try to make this as 0, C2 minus C1, when we were in the process of making the second this as 0, which is this element as 0, right? So we already got the unit matrix. The third step is what? You have to make this as 1, which is already 1, and the fourth step is to make this as 0, which is already 0. So we have to stop here and say the inverse of A is this matrix. 1 minus 1 minus 1 and 2. So if you multiply these two, you will get unit matrix. You will get the unit matrix, which is your identity matrix. We call that as an identity matrix. So therefore your A inverse, of A is equal to 1 minus 1 minus 1 2. So this is your inverse. This is the answer. This is the inverse of A. So all of you can pause the video and take the notes. Fine. Okay, now you can do the remaining problems. You can do 3, 4, 5, 6, 7, 8, 9, 10, 11, even 13 and 14. I'll do 12. Rest of the problems you can try. Fine. So I will say you can do it yourself. Do it yourself for homework. These problems. You can do third problem, 4, 5, same method, 6, 7, 8, 9, then do 10, then do 11, 13, all this. Fine. And 14. I will do the 12th one. 12th one I will do. All the 2 cross 2 matrices, you have to find the inverse using the same logic. Fine. So I will do for the problem number 12. So problem number 12. 12 is, the question is 6 minus 3, A equal to 6 minus 3, 2 minus 2 1, sorry, minus 2 1. 6 minus 3 minus 2 1. So that is my 12th question. Now we will find the inverse using, we'll use row operations. We can even use column operations, any one of them. Even if you want, we can use column operations, doesn't matter. So I'll use row operations. Fine. So in the row operation, what do we write? If it is the row operations, we will write A as I into A. That is the first step. And then we have to go and change the order. So this will be S1, then this will become S2. This is your S3 and this will become S4 if you are going to apply row operations. Right? The first step, this should become 1. Then second step is this element should become 0. Third step is this should become 1 because it is a box. Fourth is this should become 0. Circle. Right? So A is 6 minus 3, minus 2, 1 equal to I is 1, 0, 0, 1 into A. Now we are going to apply series of row operations to find the inverse of this matrix. Now again, what do? We have to make this one as 1. That is the first step. Right? So inverse of this matrix we have to find. So we have to first make this as 1. So which means we have to make this as 1 using this row. Either we have to make this as 1 using row 1 itself, or we can make this as 1 using row 1 and row 2. So we can't add or subtract or multiply something with this, then nothing will make it. If you add, I'll get 6 minus 2 as 4. If I subtract, I'll get 8. Or if I do this with 2 times this or 3 times this, I'll either get 0. I don't get 1 using R2. So very easy to make this 6 as 1 is, we will write R1 implies R1 by 6. I'm going to divide each element of row 1 by 6. Then it will become 1. It will become minus 1 by 2. Minus 3 by 6. So row 2 no change. Equal to here also 1 by 6, 0, 0, 1. A. Each element should be divided by 6. So 1, row 1. Row 1, all the elements of row 1 should be divided by 6. So 1 by 6, 0 becomes 0. 0 by 6 is 0. Row 2 I am writing as it is because nothing is changing. Only row 1 is changing. So that's the first step. Now second step, what do? We have to make this, second step is this. We have to make this element as 0 using this. How to make this element as 0 using this? We will say R2, this is in row 2. Row 2 is row 2 plus 2 times row 1. 2 times row 1 means 1. 2 times 1 is 1. 2. 2 times 1 is 2. 2 minus 2 plus minus 2 will become 0. So we will apply R2 implies R2, which is minus 2 plus 2 into 1. Plus 2 into 1. 1 is R1. 1 is in the position of R1. So this we will apply. So no change to my first row. 1 minus 1 by 2. Always it's better to write the row which does not change or the rows which don't change. It's always better. Now second row, this is what? Minus 2 plus 2 times 1 is 0. Now 1 plus 2 times 1 by 2, that is also 0. Now 0 plus 2 times 1 by 6 is 1 by 3. Now 1 plus 0 times 2 times 0 is 1. Now what we have got? Now we got into a situation where a particular row has become 0. When we are trying to find the inverse, if a particular row or a column becomes 0, which means all the elements of a particular row or a column become 0, then we have to stop the process. We can't proceed further because we can never make this element as 1 using any of the operations. So we have to stop the process here, and we should say that this matrix does not have inverse. So therefore we will say therefore A inverse does not exist. Now we can give the reason. Since all elements of R2 is equal to 0, since all the elements of R2 has become 0, therefore A inverse does not exist, which means this particular A, the given matrix, does not have an inverse because we got a particular row where all the elements are 0. Sometimes we will get all the columns as elements of particular columns as 0, all the elements in a particular column as 0. In that case also we should stop and say inverse does not exist. Fine. So other problems like 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 I have done now. 13 and 14 you can do. You can watch my next video for the continuation of 15th, 16th problem and all that, where we have to find the inverse of a matrix. We will find the inverse of a matrix, and that matrix is a 3 cross 3 matrix. We will find the inverse of 3 cross 3. The 15th problem, 16th and 17th and all, to find the inverse of a 3 cross 3 matrix. So that I will do it in my next video. You can watch my next video for the continuation of this. So you can do all this in the similar way. You will either find an inverse, or you will get into a situation where a particular row or column will have all the elements as 0. In that case you have to stop and say inverse does not exist. Fine. So all of you can pause the video, take the notes, and I will meet you in the next video for the continuation of this, which is 15th problem we will do from exercise 3.4. Thank you for watching. See you all in the next video. Thank you.